Hello friends, we start with our next problem solving session. Again, this session is for initial condition, in which now we'll see how the different type of problem in terms of inductor and capacitor using Laplace transform is solved. Okay, because you have seen there are certain problems which you can directly not able to solve through the differential equations based technique that we have already covered in our previous sessions. So how those problems will be solved, that we will see. Although that is coming under second order differential equation, but you will see second order differential equation based problems be never asked. I mean, the solution for voltage and current will be never asked in examinations. Why? Because it is a very lengthy process. However, there are certain questions in terms of second order is asked in your examination. So we will see how we solve without using second order differential equation, and we will solve with the help of Laplace transform. So if still you have not subscribed, like and comment my channel, please do it. Please subscribe it. Once you subscribe it, it will be more easy for you to go through my all previous sessions. The link of my previous video is already mentioned in my description box, so you can go through it. So we start with our next problem solving session, especially for Laplace transformation. Okay, so we have seen initial based problem using Laplace transformation. This is our topic. And we have seen three different type of elements, that is R, L and C. If I talk about, let the voltage Vt, so it is given by R into It. So as I said, now we are talking about Laplace transformation. So the first foremost important thing is, what is Laplace transformation and why it is used? Okay, so as I said earlier, there are certain problems which we are not able to solve through the time domain technique. So in that type of problem, what we will do, we will use a Laplace transformation technique to solve such problems. Okay, so there is a two term known as Laplace transformation and Laplace domain. Okay, so there are two terms. Laplace domain, it is represented by S. It is represented by S, and the value of S is basically sigma plus of j omega. If you take sigma as 0, the value of S comes to be j omega. This is our Laplace variable. Okay, and why we have taken sigma as 0? Because we are mainly interested in frequency domain analysis. Okay, so if I convert this Vt into its Laplace transform, so that comes to be Vs. Similarly, if you convert It in Laplace, that comes to be as Is. Since resistance is not a time varying element, so you can say that the value of Vs is equal to R into Is. So this is first thing which we have seen in case of resistance. Okay, this is the case of resistance. Similarly, if you talk about, this is all about the resistance. If I talk about L, we have seen V, the voltage L T is equal to L di by dt, or you can say this is also a time domain function, that is current It. Okay, now if I convert this into Laplace, so you can say that again VLS is equal to the value of L as remain as it is. Your d upon dt is a differential function, and when you convert into Laplace, it is basically represented by S. So that comes to be S, and here I will take it as capital I. I will take it as capital I, so that comes to be SIS. Here one more term is coming as I0 negative. Now why I have taken this I0 negative? See, it is also represented in the form of SIS minus of I0 also. Basically this I0 negative or this I0 is same, that is an initial current. Okay, that is an initial current. We have seen that your inductor possesses an initial value. if at time t equal to 0 negative, if you want to know whether your inductor are initially charged by some current, so that we have already seen in our number of sessions that yes, at t equal to 0 negative we will find. So basically this represent the initial value of current which is present in inductor. So when you convert this time domain into Laplace domain, so you have to take all initial conditions in your consideration. So since it is a differential equation, so you have to consider that initial condition also. So if you convert this VLT into this form, that comes to be VLS L bracket, it is SIS minus of I0 negative, and this I0 negative or I0 is your initial current. So basically what I want to suggest here is this VLS is in the form of this value, which is basically the voltage across the inductor. Now we'll try to understand this function, why it is VLS and what is the significance of this, because it is more important to understand the significance of this function. Okay, so this we have this we will try to understand here. So here I should write this equation as VLS is equal to L S of IS minus of I0. Don't confuse with 0 negative and 0, it is both initial current. So that means if inductor is in this form, say this is L, and if some initial current I0 is flowing, so when you convert into Laplace, what will happen? This inductor will represent in this form. For the time being, let's consider some voltage is here as VL. So here also some voltage VL, and this inductor is represented by a current source whose value is I0, and now this is SL. Okay, once again try to understand it. This is a time domain representation. When you convert into Laplace, what will happen? This L will become SL, and whatever the current here is there, it is I0 will become I0 by S. So when you convert into Laplace, so this is the function, and here it is VL, you can say it is VLS. Okay, and if you solve this, you will get this as your final value. How? Just solve it. If I solve, this comes to be by source transformation technique. I will solve it. This is your VLS as mentioned here. This is your SL, since it is basically your reactance, inductive reactance. Okay, SL, this is SL, and this comes to be SL into I0 by S, and this S and this S get cancelled out. So if you again redraw it, so that comes to be plus minus of VLS, and this is your SL, and here is a voltage source whose value comes to be L I0. Now if you apply one KVL, so you will get it as VLS plus of LI0, that is equal to SL into IS. If I consider that some current is flowing here as IS, yes, here it is IS, here it is IS. Okay, so from here you can say that the value of VLS is equal to SL into IS minus of LI0. Now if you compare this and this, these are the same expression. If you take L as common, this comes to be SIS minus of I0. So from here, yes, we understand that the value of voltage in Laplace domain, that is VLS, is given by L SIS minus of I0. Okay. Now a very important question comes to your mind, that how this SL comes here. Okay, this is in your mind, how this SL comes here. So this is basically a transformation technique. Just keep in mind, if inductor is in this form, so in Laplace it is represented in this form, it is represented by SL. Basically it is a reactive reactance, it is an inductive reactance, and this I naught, since if initial current exists, that initial current will be represented parallel with this inductor in the form of I naught by S, and once you transform it, so which we have already seen, this value is coming. So from here and from here, this is clear that your voltage is represented in this form. Okay, or you can say that the inductor in Laplace domain, if it is initially charged, is represented in this pattern. Okay. Actually, I told you that R is basically resistance, and there another term comes known as Z, which is known as impedance, and it is in the form of Z equal to R plus of J X, where R is your resistance and X is your reactance. This is your resistance and that is your reactance. In our AC analysis, we will more try to understand the difference between the resistance and reactance and how to take part in power consumption patterns. But here R is your resistance and X is your reactance. Okay. In case of inductor and capacitor, we will consider this as, if I talk about the inductor, if we talk about the inductor, this Z is basically given by JXL. Very important, it is given by JXL, and we call it as inductive reactance ZL. And the value of XL is what? The value of XL is omega L. You people already studied all this, so you can put that value, so that comes to be J omega L, and as I said, the value of J omega is S, so that comes to be ZL. So your impedance in Laplace is given by SL. If you talk about the impedance of an inductor in Laplace domain, so that comes to be what? It is SL. Very important. So that's how that value of SL comes. So this is all about the impedance, that is, I'm talking about the inductive impedance. Now we'll talk about the capacitive impedance. If we talk about the capacitive ZC, it is given by R minus of JX. You have seen this is given in this form. Okay, or you can say it is R plus of X by J. If I multiply J and divide by J, so that comes to be R plus X by J. This X is basically known as XC. This X is basically known as XC. If you talk about the value of XC, that comes to be 1 by omega C. So from here, if resistance is very less, we will only interested in reactive capacitance. So that comes to be XC by J, and that comes to be 1 upon J omega C. And as I said, the value of J omega is S, so the value of ZC comes to be 1 by SC. Okay, the value of ZC comes to be 1 by SC. Okay, and it represents the capacitive impedance. Okay, it represents the capacitive impedance. So from here we understand that yes, ZL, it is represented in the form of SL in Laplace domain, and capacitor in the form of 1 by SC in Laplace domain. Okay, so these two things are very important, and based on these two concepts, we have to solve all the problems. Okay. Now if I talk about the capacitor, as we have seen for resistor, inductor, now we'll talk about the capacitor. You know the value of current IC in capacitor is given by C dV upon dt. Yes, or for the time being, if you call the voltage across capacitor is Vc, so it is dVc by dt. If you see, this is a time domain current, so it is represented in this form. And now if you convert into Laplace, this comes to be C. In similar fashion, we should write it as S VCS minus of Vc 0 negative, or you can write it as C SVCS minus of Vc 0. These two are the initial value of voltage across the capacitor. Very simple. So from here I should write it as ICS is equal to C into SVCS minus of Vc 0. Now we will see whether this assumption or this equation is correct or wrong. Capacitor having value C and having voltage appeared as Vc and current IC. So in Laplace domain, if you talk about in Laplace domain, this capacitor is represented in this form. This is your now ICS. This is 1 by SC as I mentioned earlier, and this is Vc 0 upon S. This Vc is basically, here this Vc represented the voltage across the capacitor. However, I have taken that some initial voltage V is present. So for the time being, I will call this voltage as V0 voltage. Okay, so actually here this equation will represent in this form as VCS minus of V0. This V0 is your initial voltage across the capacitor. Okay, so from here also I will write it in the form of V0 by S. So this is basically the representation, and as we have considered the entire voltage is Vc, so this voltage is VCS. Okay, now if you solve this, if I solve this equation, so this comes to be VCS minus of V0 by S, V0 upon S, that is equal to 1 upon SC into this ICS. Yes, simply multiplied by SC and rearrange this. If you rearrange this equation, this comes to be ICS, that is equal to, I've taken C as common because it is multiplied in both the term, so that comes to be S VCS minus of V0. So if you see, these two equations are same, this equation and this equation. Okay, once again I will explain you. This ICS is C into SVCS minus of V0. Vc is the voltage which is appearing across the capacitor. However, the initial voltage which is present across the capacitor, which we have considered as V, it is basically your initial voltage. You can write it as V0 also. This we have considered that our capacitor is initially charged. Okay, so if your capacitor is initially charged, so whenever you convert into Laplace domain, this is the representation. It means this capacitor along with this voltage source whose value is V0 by S. This V0 is what? This V0 upon S. Why we are taking in denominator S? Because this voltage which is coming here is a positive voltage, or you can say it is a unit step voltage, or it is a DC voltage. So that's why when you convert this into a Laplace domain, this comes to be in the form of 1 by S, because the transformation of ut is what? It is 1 by S. We have already seen. So this is all about the capacitor. You will more understand during the numerical sessions. The last and important thing is our three basic function. The Laplace transform of del t is 1, Laplace transform of ut is 1 by s, and the Laplace transform of rt is 1 by s square. So these three function will be widely used while solving the problems. Always keep in mind, whatever the independent voltage and current is given in the circuit, this voltage V is in the form of unit step and this current is in the form of unit step. So whenever you convert these two into Laplace, okay, it is always coming in the form of V by S and I by S. V and I, whatever the value. If it is 3 volts, so it is 3 by S. If it is 2 ampere, it is 2 by S. Okay. Why? Because it is a positive voltage, or it represents a unit step voltage, or it represents a DC voltage. Okay. Since we are now talking about only the DC, that's why I have considered this UT. Okay. Sometimes it is del T also, so it comes to be 1. Sometimes it is RT also, it comes to be 1 by S square. So accordingly, you have to put and find the solutions. Now, we will see one problem. So this is your question, friends. This is your problem. Now it is a different type of problem in which there are two different inductors are connected with two different conditions, and that's why this Laplace transformation technique is used to solve such type of problem. Because if you apply this problem, if you solve this problem using our conventional technique of the current and voltage solution for inductor and capacitor, it is not possible, because here the condition is different. At t equal to 0 negative and at t equal to 0 the condition is different. So under such circumstances, we will apply the Laplace transformation technique and one can easily get the answers. Okay. So in this problem, you have to find VLT, this voltage you have to find for t greater than 0. Okay. The condition of switch already mentioned as at t equal to 0 the switch is moved to position B. At t equal to 0, your switch, if it is S, so S is at position B. That means at t equal to 0 negative, S is at position A. Yes. So these are the two conditions here. Now if I draw this at t equal to 0 negative, we will see this at t equal to 0 negative. So this is your resistance, this is 1 volt, this is 1 ohm, and your inductor will behave like a short circuit. And if let some current is flowing, say this current is I1, okay, so I call it as I10 or I10 negative. So you can say that the value of I10 negative is 1 ampere. Okay, that means you can say that I10 positive is also 1 ampere. It means initially this inductor is energized by a current source of 1 ampere, but this inductor is unenergized because there is no condition mentioned for this inductor. So if you draw now at circuit at t equal to 0, keep in mind for Laplace transform also you have to draw the circuit at t equal to 0 to solve the problems. So what will happen now, please see, at t equal to 0 the switch is in position B. So if this is your inductor, this is your first inductor, and it is an energized inductor by some current, so it is represented in this form. This is your resistance as it is, and again this is your inductor, and here is the voltage VL. Now it is S. Now I am converting entire this into S, Laplace. So this is 1 by 2 ohm, this will become 2S. Simply SL, L is 2 Henry, so it is 2S. Now here if you see, this is S, very simple. it is 1 Henry, the value of L is 1 Henry, so SL, okay, I already told you. So it is what? S into 1, that comes to be S. So it is S, this is 2S. What is the current here is 1 ampere. I told you it is I naught by S, so that comes to be 1 by S. So now very simply you have just find the circuit at t equal to 0. Now this is your circuit at t equal to 0 and everything is converted into Laplace variable. Now you have to simply find the answer. Okay. Now for solving this, I'll apply the source transformation technique. This comes in this form. Whatever the direction of the current, that represent the direction of the source. Since it is in the downward direction, so that comes to be plus minus, very simple, and like that I have placed here. So in source transformation, this is S into 1 by S, that comes to be 1 volt. Okay, this is 1 volt. Why? Because it is S into 1 by S. This is 1 by 2 ohm and this is 2S. Okay, now just solve it and get the answer. Simply you can apply one KCL at these nodes, because at these nodes the voltage is VLS, so that comes to be VLS minus plus 1 upon S plus of VLS 1 by 2 1 2S. So this is the value of VLS, minus 2 by 3 plus 4S. If you solve it, that comes to be VLS is equal to, if you take 4S common, so that comes to be minus 1 by 2 into S plus 3 by 4. So from here, if you see this, if you take the inverse Laplace transform, the VLT comes to be minus 1 by 2 e to the power minus 3 by 4 t, it is ut, very important. This is the answer. You know the Laplace transform of 1 upon S plus 3 by 4. I am not going in that detail because you already know. So like that you can solve it and find the answer. So this VLT is minus 1 by 2 e to the power minus 3 by 4 t ut. Okay. So this is the problem and in this manner we have solved it. Here one more important thing is your time constant. If you talk about e to the power minus of 3 by 4 t, I told you it comes in the form of minus t by tau. So if you compare here, tau comes to be 4 by 3. So this 4 by 3 is basically a time constant. Okay. So for this circuit, the time constant tau comes to be how much? It is 4 by 3 seconds. This also you keep in your mind, because sometimes this questions comes to be in examination and they will simply ask the time constant. What is the time constant? So for time constant, you have to understand the network and then you have to find it. This is 4 by 3 second. Okay. So this is first problem. We'll go for the next problem. So this is your next problem, friend. In this problem, you have to find VT, this VT, across the capacitor for t greater than 0, and this is the condition of switch. It means initially the switch is at position A. After some time at t equal to 0, the switch is going to position B. Now, if I draw this circuit at t equal to 0 negative, so this should be the condition. Your capacitor is open circuited with, let some voltage is known as V0 negative. Okay, and this value is 12 volt. So you can say that V0 negative, that is V0 positive, comes to be 12 volt. That means here initially the capacitor charged by a 12 volt. Now if you draw circuit at t equal to 0 simply, so this is your circuit at t equal to 0. But while drawing this circuit, we should keep in our mind, we will directly convert into Laplace, and here the voltage which is present here as Vs. Now this is SL, so you can say it is 0.25 S. Okay, this we have find as 12 by S. It is 12 volts, so it is 12 by S, and this value is 1 by SC. Okay, so how much it is? 1 by S into the value of C is 10 into 10 to power minus 3 in millifarad, so it is 10 to power minus 3, so it will go up, so that comes to be 100 by S. So this value is basically what? 100 by S. And now you have to find the value of Vs. Okay, you have to find the value of Vs. Now simply you can find by applying KCL. This Vs is the voltage which is appearing at this node. So you can say that Vs minus of 12 by S upon 100 by S plus of Vs divided by 0.25 S, that is equal to 0. Yes? Should we write this equation? Yes. Now we will solve it, so that comes to be SVS minus of 12 upon 100. Okay, I have just solved it, and that comes to be, you can write it as 4Vs upon S, that is 0. Simply multiplied by 100 and S, so that comes to be S into SVs minus of 12 plus of, that comes to be 400 of Vs, this is 0. Or you can say it is, take Vs as common, so that comes to be S square plus of 400. Okay, that is equal to 12 of S. And from here you can say that the value of Vs comes to be 12S upon S square plus of 400. This is the value of Vs. Now if you solve this, simply you have to apply the Laplace transformation technique. This Vs is what? It is 12 into, you can write it as in the form of S upon S square plus 20 square. If you take an inverse Laplace, so that comes to be Vt, and this comes to be 12 cos of 20t. Yes, this is the answer. So now you understand how we have solved this and get the answer. Okay, so that's why we are using Laplace, because it is not possible using our conventional techniques. Okay, we'll go for the next problem. In this problem, friends, you have to find V0t for t greater than 0. The condition is given as initially the capacitors are uncharged. If it is not mentioned, then you have to find, and if this is a type of circuit in which no switch is mentioned, that means definitely the capacitor is initially uncharged. So in such type of problem, how we will solve it? Now the source is a kind of impulsive source which is given here. So what we will do, we will directly draw this circuit in terms of Laplace transformation. Okay, this is 2 ohm, this is I. If I convert into Laplace, so that comes to be 1 by S, because the value of C is 1, so 1 by SC, so it is 1 by S into 1, so that comes to be 1 by S. Okay, this is simply your current source of value 4I, and this is your 1 ohm resistance, and this comes to be 5. Why? Because the Laplace transform of del t is what? It is 1. This concept we have used here, and the voltage here is V0. For the timing I am writing it as V0, basically it is V0S. Okay, just to find it. Now this voltage will appear here, and if you see this I and this 4I will add it and get here, and the current here is what? 5I. Now if you apply this KCL, you can say that V0 minus of 5 upon 2, okay, plus V0 by 1 by S, this current, and the current which is coming here, so that current comes to minus of 4i, that is equal to 0. So from here you can say that it is v naught minus of 5 upon 2 plus of s v naught minus of 4i is equal to 0. Say this is our equation first. Now we have to find the value of I to get the value of v naught. From here you can say that v naught upon 1 by s, now it is an impedance here, that is what? This is what? Basically current which is flowing here. And what is the current here? It is 5i. So v naught upon 1 by s, that is equal to 5i, is the current which is flowing here. Yes, you can say that. So from here you can say that the value of I comes to be SV naught upon 5. This is the value of I that you will put here and get the answer. Okay. So now what we'll do, we'll solve it. Just multiply it by 2 in this equation. So that comes to be v naught minus of 5 plus of 2s v naught minus of 8i, that is equal to 0. Take v naught as common, so that comes to be, or instead of taking v naught as common, first we will put that the value of I comes to be minus of 8 into s v naught upon 5, and this is what it is, v naught minus of 5 plus of 2s v naught multiplied by 5, so that comes to be, and take v naught as common, so that comes to be 5 plus 10s minus of 8s, and that is equal to 25. Okay, or you can say it is v naught is equal to 25 upon how much it is, 2s plus of 5. If you take 2s common, that comes to be v naught is equal to 12.5 upon s plus 5 by 2. So v naught t for all time t, that is 12.5 e to the power minus 5 by 2 t. This is the answer. So this is our next problem, friends, in which you have to find v naught t for t greater than 0. Now this is another type of problem, and we have to find the value of v naught t. So as I told you, it is for ut, that means initially your inductor and capacitor both are unenergized. So what we will do, we will directly draw at circuit at t equal to 0 just to find the values. So that comes to be, now this is SL, so that comes to be S because it is 1 ohm, 1 Henry, this is 2 ohm. Here is the voltage is V naught. This is 1 by SC, so it is 0.25 into S, or you can say it is 4 by S. Okay, and this is 10 upon S plus of 2. Okay, e to the power minus at has a Laplace transform of 1 upon S plus of a. With this I have mentioned here as 10 upon S plus 2. Now this V naught is basically V naught S. Okay, this V naught is basically V naught S. Now can you find it? Yes, this is your V naught. Simply you apply a KCL and find the answer. So that comes to be V naught minus of 10 S plus 2 upon 1 plus of, this comes to be V naught upon 4 by S plus of V naught upon S plus 2, that is equal to 0. It can be added, why? Because it is now in the form of impedances. So it is S plus 2, it is V naught by 4 by S, and it is V naught minus of 10 S plus 2 upon the resistance here is 1. So now you can solve it and get the answer. Okay, now it is simple to solve it. So that will become a little bit, we will solve it. This become S V naught by 4. This is V naught upon S plus 2. And what it is? It is S plus 2 into V naught minus of 10 upon S plus 2. So you just multiply it by S 4 into S plus 2 and get the answer. It is not that much lengthy, and such type of problem will comes. Okay, so that comes to be 4 into s plus 2 v naught minus of 40, I have just multiplied plus of s into s plus 2, okay, into v naught plus of 4 v naught, that is equal to 0. This is our equation. Once again we will verify it. 4 into s plus 2, so that s plus 2 will cancel out, so it comes to be 4s plus 2 v naught minus of 40 plus of it is s into s plus 2, and that is 4 v naught. Okay, now you solved it. Take v naught as common. I am solving it. It is 4s plus of 8 plus of s square plus of 2s plus of 4. Okay, that is equal to 40. If you take this v naught, it is s square plus of 6s plus of 6s plus of 12s, that is equal to 40. Or you can say the value of v naught comes to be 40 upon s square plus 6s plus 12. Now this is simply a mathematical rearrangement. Here you can say v naught s is what it is, 40. I should make in the form of s plus 3 whole square. So it is s square plus 9 plus 6s, okay, and 9 will come here, so that comes to be root 3 whole square. Should I write in this form? Yes, I have just rearranged it. So that is 40 upon root 3 into root 3 upon s plus 3 whole square plus root 3 whole square. This is just a mathematical rearrangement. So your v naught t comes to be 40 by root 3 e to the power minus 3t into sine root 3t. This is your answer in volts. This is your answer.